So let's draw a strophoid with a focus on F, any point F, and node at point N, and this line here that passes through N. So a strophoid requires these three objects, okay? 2 points, F and N, and a line that passes through N. We're going to be using this point here on the line as a parameter. Now to draw a strophoid, and I'll explain what exactly kind of a locus it is, what you first do is you draw a line passing through both F and N, and then you draw a circle that is centered on N, but passes through the node N. Okay, now what the circle is going to do is show you along this line which 2 points are equidistant from N, okay, at a distance that is equal to the distance between N of t and the node itself, right? So let's go ahead and intersect the circle with this line, and these two intersection points here, they are a distance away from N, which is equal to the distance that N is from N, such a way that if I move this construction around, you can see here that those intersections are moving. Now the strophoid is nothing but the locus of these two intersections over all N. So let's go ahead and use the locus tool in GeoGebra, and I'm going to say I want to draw the locus of this point with respect to all positions of N of t on this dotted line. So you get this lobe, and then if you draw this over here, the locus of this guy here with respect to all N, you get this locus. So let's go ahead and turn off or stop showing the circle, the two intersection points, and let's just look at the geometry of the strophoid. So in fact this guy here also becomes immaterial, right, for our purposes, and what I can do now is paint this guy just for visibility red, and paint this remainder of the curve also red. Okay, so you can see here that the strophoid will vary as I move the focus around. By the way, if the focus is right above N, it's a perpendicular line with respect to this baseline here. Okay, this strophoid has this axis of symmetry, and we call this a right strophoid. But in general, strophoids are oblique. They don't have an axis of symmetry. Okay, and you can see here that they transition. They always have a node, so this is not a regular curve because it's a cubic with a singularity. So it's not differentiable over here. Okay. All right. So what else can I say about this? All right. So here's a very interesting construction that Arseny Akopian taught me. If I have a few points on a strophoid, how do I locate its focus? Right. So if I was only given the curve, it would be obvious for me to locate the node because that's the single self-intersection of the curve. But how can I locate the F starting from points on the strophoid? It turns out that if you invert the strophoid, so if you think of its inversive image with respect to a circle going through the node, okay, so let's use this as the inversion circle. Let me paint this guy here some reasonable color. I like to make my inversion circles be gray and dotted. Okay, so this is any old inversion circle with some chosen radius. Okay, now if I take all the points on the strophoid, and perhaps I should bring back one of those points, but if I invert those points, I get a right hyperbola, a rectangular hyperbola. So let me try to bring back those 2 points. I had this guy and that guy, and recall that they were predicated on the motion of a particular point on that straight line, right? So here are the 2 points. Now what I can do is I can invert one of these points with respect to this circle. Let's do that. I'm going to reflect about circle. Let's reflect this point about this circle, and let's reflect this point about this circle. Okay, and now let's use the locus tool again to see what they sweep over all N. So I'm going to hit here and make it sweep, and I'm going to hit here and make it sweep. Now you can see that this is clearly a hyperbola. Okay, and it turns out that this is a rectangular hyperbola, meaning that its 2 semi-axes are equal. Okay, so no matter what my you know, the aspect of my strophoid is I'm always going to invert it with respect to a circle center on n onto, and let's make this hyperbola b, just for the sake of my historical experiments with it, light blue. Okay, so here we go. Very good. Now, one thing you can ask yourself is, and it's a very important element of this inversive image, is where is the center of this hyperbola? Now, for me to compute the center of this hyperbola, since I'm still using the locus tool, you cannot do that in GeoGebra. So what we need is 5 points on the hyperbola, and then we can put a conic through it and ask GeoGebra to report us its center. So how many points do I have on the screen here that already lie on the hyperbola? I have this inversive image, I have this other inversive image, and then it looks like the hyperbola also goes through the node, right? Although the inversive image of the node with respect to the circle is at infinity. Very well, so we have 3 points, let's get 2 more, and to get 2 more, all I need to do is, for example, I could invert the focus, right? So I can say, reflect about circle, where is this focus with respect to this circle? Oh, it's right there, okay. And now we need a 5th point, so to get a 5th point, let me put a point on the curve, any point on the curve. Here you go. And I'm going to invert this one with respect to the circle. So I do this, and now I have my 5th point in the hyperbola. So now I have 1, 2, 3, 4, and 5, right? So let's give these guys names here. So now I'm going to do a conic, right? So I can use a GeoGebra tool. I was going to do this by hand. I'm just going to do this like this. So I'm going to click on 5 points. 1, 2, 3, 4, 5, and I'm going to recover the exact same conic. You can see here that this black conic, which I believe I have generated, yeah, so no, this is not what I want. I want to turn off the locus and just show the black conic, which is passing through these 5 points that are on the screen. Okay, so 1, 2, 3, 4, 5, and all I'm doing here is I'm showing that they are the same. Okay, now I'm going to go ahead and switch back to the locus, which I had drawn blue before, and what I want to do now is I want to ask GeoGebra what the center of that conic is. Okay, so I can do that numerically, right? So I can just say here, once it allows me to do, I can say right here, center of the conic, and it's called E now, so there's the center. Now we're gonna get to the algorithm to find out where the F is, right? So let's go ahead and color that guy blue as well, and I'm gonna just give it a center label O. Okay, so now one thing is already apparent, and this is the property. The image of F under the inversion, which is shown here as F prime, is a reflection of the node with respect to the center of this rectangular hyperbola. So an algorithm for one to obtain the focus, and here I did use F as one of the 5 points, but I could have used any other point on my strophoid to get the 5 points that I needed to build this rectangular hyperbola. So an algorithm to obtain F is simply to reflect N about the center of the rectangular hyperbola to obtain the inversive image of the focus that you're looking for. Okay, and you can see that all these guys are obviously collinear. Correct? So we got the node, the center of the inversive rectangular hyperbola, the inversive image of F, which I'm calling F prime here, and the focus itself. Okay, so that's what I wanted to cover in this video. I'll see you on the next one, where I'm going to show a few properties of the strophoid over triangles and quadrilaterals. See you on the next video.